Good afternoon. My name is Patrick van Velde. I have some good news for you. I'm the last speaker before the lunch, so bear with me half an hour. I have some bad news. I'm not going to talk about BIM, so that's maybe a disappointment. But the interesting maybe is I want to inform you about asset information management. And asset information management in industry. Why in industry? Because industry is a very asset intensive business. If you look at normal, let's say CapEx investment, maybe 20% of that is within building, but 40–50% is within equipment and materials. And so you have to manage that. Maybe also important to know is my background. My background is I used to be a project manager for industrial projects, and in Europe that means mostly brownfield projects, meaning adaptations of existing installations, which means also as a project manager you are bound to deliver projects. You are bound to deliver some solutions. And then in that respect, I was fully aware of what attention is given to accurate data, accurate information, and some accessible data. And I was fully aware also of the cost when there is a lack of data. So I'm not, let's say, the software developer or something, so don't ask me about files, formats, or something like that, but I'll give you some practical hope information. So maybe one back, sorry. So maybe this is a typical industrial installation, let's say a production part, and tank farms in feedstock and summer products. I mean that this is an average industrial company, meaning 50 million euros of revenue, sales revenue a year, and a capital asset of 150 million euro. Right? So there you have some reference. Well, this is the production facility of that. What I want to do with you is to at first give you some basics about what is asset information management in industry, go to the business perspective, which is of course the important thing, give you some functionality, how it works, and also then to the present, but also to the future, how do we explore some, let's say, the visuals and the workflows and get some conclusions in. Maybe at first to have a link, so Patrick van Velde from the company Sweco. First, a link between Sweco and asset information management. Maybe that's not so clear. Sweco is the engineering company, European leader, let's say. Within the countries where you see is in brown or the yellow maybe. 14,500 employees, capacity to provide widest possible range of services. But also we contribute our expertise in all phases of the life cycle of the project. And that's the important one, right? So me, myself, and Mindaugas, who is also present here, who is the responsible in Lithuania. This is the, let's say, the life cycle. I don't want to now explore this, but I come into later. As a Sweco, we are used to work in industry, but also infrastructure, energy, and building, so we know what it's about. For an industry viewpoint, these are our activities, and you see asset information management is one of them. In refineries, for instance, in some chemical business, in manufacturing, or in some pharmaceutical business. This is an example of a project we did 5 years ago. This is a typical project in industry. It concerns a chemical plant when there is a shutdown every 3 years. So the plant goes idle for a few weeks, and then in that period you have to implement all of the CAPEX project. So in that respect there was 40 projects which had to be installed in a 6-week shutdown period. Activities are there, all kinds of activities, but then you see what attention you have to give to data. For one, the as-is situation, that must be clear to build upon your design. And for two, let's say the handover from engineering to some operations, which is also very important to start up the plant, the installation again. And that makes, let's say, the success of these summer projects. From that on, we explored or we developed, let's say, the service and the model around some asset information management, which is at that time was a survey on the as-is data and also a focus on procedures of handovers and management, which led to a business model for us, for Sweco, where we implement for plant owners the asset information management systems. We execute what we call the management of change, so all small modifications in a plant. And we do that in most cases on our own server configurations, where the client links in. So he doesn't have to bother with, let's say, IT, infrastructure, etc. Why should you do asset information management as a plant owner? It's all about some sound operational management. And I'll come to it later. One driver is there, of course, let's say the cost. You're always talking in terms of cost and money. It's also to do with compliance. Compliance with environmental regulatory requirements in industry. If something happens in the world of industry, the next day there's a new rule or a new requirement you have to comply with. So that's a very dynamic issue. It's also about some bridging the gap between CAPEX and OPEX. Maybe that's not a CAPEX is some capital expenditure, which is some building projects. OPEX is about operational expenditure, how to operate, how to maintain an installation. That's for now, but what for the future? Asset information management becomes even more critical because of, let's say, the economic context in industry, at least in industry, is that it's tough. So as a plant operator, you have a few choices. You close down your plant, or you move to Asia, or you optimize the plant. You get the maximum out of it, meaning someone debottlenecking it and operate the equipment beyond its financial life. So depreciations are already being made. But beyond that, if you can operate your plants and beyond that, it gives you a real revenue. And that's all about asset performance management, where asset information management is supporting. So managing the extension of aging assets. For some basics in asset lifecycle information management, you see here the different stages of an installation, from feasibility concept to permit engineering, which is called basic detail engineering, the building, but the startup, that's the most important one, the maintenance, operation, inspection, and then debottlenecking the installation or some decommissioning it. Then you have the data, which is according to that phasing, which is as I'm concepted, as I'm designed, as built, as is, and as end of life. And what for a plant owner is the most important is the as is, which is not the same as the as built status. And that to consider that's already an important one. If you look to the systems which are involved, in a concept stage, you are very much involved with system engineering. There are the user requirements, and you always refer back to the user requirements as you develop it. Then, of course, in a design stage and a build stage, you are concerned with some 3D modeling. But then in a maintenance phase and operation phase, you are concerned with asset information management. In an ideal world, all data which is being generated from the start within some system engineering or some 3D modeling is being pushed around through the phases, up to an asset information management system. But that's the ideal world. And an ideal world doesn't exist. It will not exist. Surely not in industry. So you have to look for other ways to manage your data, which is more of a pull instead of a push, that you pull from an asset information management system these data, these information that you want. You ask a question, and then you are going to look where are the relevant data, and then you'll put them in. From a database perspective, well, it's a bit, of course, but then what it's important is operational database, where the importance of requirements are and over information properly acquired, effective and access for all stakeholders within the proper rights, and information quality consistent. Another notion is, let's say, the data model. You see here different things. The first thing is you have a plant environment where is really the as-is situation, but you have also projects on that same assets, which are being developed, which will change the asset in due time. Right? But that's two different environments where you have to link them, where you have interchange between them. Of course, if you are in an industrial plant, you want everything, your assets, to be according to the standards and the specifications of that plant. You have to be consistent there. And also it's important, surely also from a compliance issue to have an archive of the history of all your assets. And then of course it's also important to have some connectors to SRP, for instance, for a maintenance system, or to some 3D design models, or for email to have the workflows running through your asset information model. And then the third thing is, it's been said already, it's not only about information, some structuring and data structure. It is these four elements which will make out, let's say, the success of an asset information management system. It's of course the information that you have to structure, but it's also about people. Huh? You have to have the buy-in of people. You have to train them. You have to. They are the ones that have to give the input. They are the ones who retrieve the information for the system. So they're very important. Of course, there next are the procedures that you have in your organization. For instance, handover management from engineering or for construction to operations. Your change management is also very important. And at last, maybe, let's say the IT systems, where you have IT systems where you have some distributed data. Back to the business case. Business case, a best documented plant. That's the view of the plant owner, of the CEO, which talks to his board of directors and says, I have every asset in my terminal 100% documented, and I can comply with my company standards, and I can prove it. That's more important. You have to show it. So that enables me to become the safest possible terminal, which is not maybe about cost, but be assured if there is a safety incident in an industrial plant, it jeopardizes your reputation in the market. It's the most flexible because it's fully in compliance and it's the lowest cost. This is an example, the same example where I started with an average chemical production facility with tank farms. You see there it's a lot of documents on paper, on databases. So in this case there were 130,000 technical documents in paper or in digital form. But also 102 databases spread around the organization. So how to manage this? How to manage also as an asset manager the intensity of change, for instance. So you have your concurrent engineering. So we see there are projects always running in the installation, which will modify your assets. You have your capital projects, where you have a mass of information and documents which ought to be handed over to operations, and then you have to manage them. Of course, some regulations, which are important, which are very dynamic. Every month you get a new rule. The dysfunctional handovers and the information silos from each of the department, as you know, I expect. This comes to information incidents, but this is I think a really important one, because the lack of data generates a huge cost. This is not this is from RC, which is an American company, which has done a survey over the last 5 years, which states that a company with, let's say, a revenue yearly of 15 million sales will encounter 750,000 euro loss because of lack of data. And this is being laid down in for instance, operating delays when an equipment fails, and you have to analyze it, and so it takes time. So the availability is not there. The lower availability, if a shutdown takes more than 2 days, which is planned, it gives a huge cost. Higher maintenance costs, higher capex, because the data is not as is, and of course safety issues, etc., which can't be budgeted, but is a really a major impact. What were the early attempts? The early attempts was the approach is We have the documentation, how do we manage them? Well, that is, okay, that's a fair good start, but that won't give the result that we are needing. So it's the other approach that we need. What do we need as data? And the second is, how do we get it? Huh? So then you begin with your equipment and to specify what kind of data, what kind of documentation you have to have for a specific equipment. This is also governed by some ISO codes, but is mainly also that you do it for your own plant. So you get there some sort of document repository, what you want for a certain equipment. In this case, general arrangement drawing, motor specification, wiring diagram, etc., etc. So this gives the notion of the best documented plant in three elements: people, workflows, content, and the platform. So from people, we said, hey, it's not only about information, some structuring, it's also about the people, because the people are giving the input, the people are asking the questions. From an engineering viewpoint and a maintenance, why did it fail, for instance? What is tested at a given moment? From an operational, how do I get it fixed? Where do I find the parts? But also for a supplier, for instance, and for the also for the regulator. From a content point of view, what is the function of this equipment? What are the design data? Also, which some procedures are on the equipment to install, to operate, to maintain. These are data which are very dynamic, and so they are bound to have some change management. The other data can be the commercial, can be status, can be history. It's more event driven, and there you have to have, let's say, an historical record of it. Then about the workflows, that's not from day one that you have very efficient workflows. It take a path forward from, let's say, data migration to have some procedures upon the data, to have processes in, to have workflows, and see that you maintain that. From a platform view, of course, one is a purpose built, which has to be some CAD independent, and where you can link some documents to assets. It has to be trusted. Where is the source of the information, of the data? Because ownership. It has to be accurate. It has to be complete. It has to be collaborative. And it has to be visible. Visible not only in terms of 3D models that you can use, but visible also in what is the status of my asset management. So, and this can be, so this has to do with some reports that you can generate to prove to whoever, the regulator, or your board of directors, what, let's say, the status is of your assets. So that's for, let's say, a bit the business case. Why do we do it now? For some practical, how do we implement it? It's all about functionality. So this is an example of an application platform, which is called Meridian, which we use. And you see here the division between, let's say, the plant environment and the project environment. where you retrieve from, this is a circuit diagram from a pump. You retrieve to the object, which is the pump, to, let's say, the data of it, which is the data, which is according to ISO 15009-26. From a document point of view, you have this same pump, within you retrieve, let's say, the data sheet, which is maybe in another system. Another thing is that what are the required SEMA documents, in the sense that you have here your repository, and you have here the status of these documents in your plant. Very much important for instance, for the handover from a project to operations. And you have here a full statement or a full SEMA status of what documents in what stage they are, and then you can focus on the actions to retrieve them. So for instance, in this, the general arrangement drawing is issued and the spare part list, so they're okay. The installation manual is still in review. We requested the vendor for the maintenance manual, but still the wiring diagram is missing. So we can go after that and focus on it, so we have a good handover management. Also, you can, from the asset information management, there's a connector to the maintenance system where you can have a work order related to that object. For instance, this is in SRP, where you have the same pump, and let's say the work order, which is due next week on that equipment. So that's let's say asset information management. But asset information management, the strength of it is if you can combine this with the visual aspect, it gives you a far more added value, because people seem to have more some recognition with a visual aspect than when it's on a list or just data. So the challenge is here to use visualization, 3D visualization, to support IAM, meaning that this is the entry to your database. So in an ideal world, that should be, the as-is information should be a 3D design model. But as we said, at least in industry, this is an ideal world. This won't come now, and this won't come in the future. So how to do this then? How to manage this? Then you can go to some sort of hybrid environment where you have realistic 3D photos combined with 3D design models, combined with laser scan point cloud models. So this is the way to go. These are all techniques which are now already in use. For instance, a scan to full 3D laser scanning to point cloud, photogrammetry, or 360 pictures. So a scan to full cut that's known, to a point cloud is also known, I think. This is, and I'm now starting up a web portal. This is a meshed photo from a drone, which takes half a day, makes 150 photos, high resolution photos. You mesh this, and you get this result. So from a chemical plant, which is of course a certain resolution, but maybe it's enough to to connect with your asset information management to retrieve the data that you want. Or you can go to 360 panorama photos. All of them, of course, has their benefits, but also their costs. If you look at 3D model, of course, it's from a data set and from geographical accuracy. This is the best. But the effort to maintain a 3D model is very huge. So if it's very huge, it's likely that it won't happen, at least not to the full. On the other hand, you have some 360 photos, which are very inexpensive. You walk around and you take pictures, that's all of it. But of course, the data set is very limited. And the link to asset information management is there. You can connect a connector with a photo, so you can link with the asset information management. Of course, when something changes and you take a new picture, you have to link again the connector. So that's, of course, something which is somewhat troublesome. But at least what our solution is that use all of the information that you have, and let's say the visible information from 3D, from laser scanning, from some photogrammetry, make it a hybrid model, and see to it that this is the connection to your asset information management model or some database. And this to do with let's say, all of the devices that you have, from laptops to your iPhone maybe, and in a stage which is very near, is, let's say, the virtual reality glasses. And this is an example. I'm going in to the web portal. Where you see 3D models combined with a laser scan model, where you have the entry to the asset information. So there's a pump. So you go via the asset information management system and retrieve, let's say, the data sheet of the pump. You must imagine within the near future that you have your virtual reality glasses. You go to the installation, you go with this, you get this on your glasses. You see the reality, you see the virtual reality. You ask them, give me the data sheet, and then this is being retrieved from the asset information management system. But this is a 3D model and a laser scan model, but you can also use the photos. This is from the same installation, but the part which is not in a 3D model, and there you can do the same. This is you can retrieve here. This is from the project database. So this equipment, this valve, this will be changed in a near project. So you see it, so you know how to handle it. This one is a valve where you have all some of the spare power lists of the valve. It can be combined with a work order, etc. So it's an hybrid environment of what you are available, 3D design model, point cloud model, photogrammetry, or a 3D photo. You combine it, but let it be the link to the asset information model. Okay, to conclude, draw back to this. This is a real case that we that we developed, where we see the benefits which are expected or maybe obvious to for compliance, reduce search time, of course, improve collaboration. But the unexpected were also that the maintenance quality was very much improved. The cost of compliance was also, because every time you get new rules, you get to generate reports, which takes much effort. So this is being done on a very efficient way. And it's a bit, I don't know what happened, but also reduced onboarding time, meaning the introduction of new people in the plant is going very much faster and smoother than in the past. To conclude, asset information management, somewhat kind of a roadmap. I always said a good asset information management is in the eye of the beholder. What I mean is, it's very different if you are in a refinery business or you're exploiting a nuclear power plant. So what you want with it is a nuclear power plant, you're very much keen on compliancy. In a refinery, you seek the link with maintenance, with inspection programs. Every plant or every project or every implementation is unique, but there are many best practices where you can rely on. The 4 elements: information, people, procedures, systems. And of course, it has to do with information management. So from a methodology, it's very similar to an IT project. I would say think strategic, where you want to go, but start small. Get some early successes, mainly also on cost savings, because this can prove to your board of directors that you have the success. And what I already said, use all visual models in a hybrid environment, because this is the most pragmatic way. Okay, thank you. I want to conclude here.